All right, so let's take a look at slope in a different way. Now, before we get into this, let's just talk about distance. So forget about graphing on a coordinate plane. Let's just talk about a number line. Now, let's say I wanted to find the distance between 1 and 5. Well, that's easy. That's just 4. Okay, but other than just counting on the number line, think about how you would get that. Well, what you would want to do is you'd want to take the point you started with and the point you ended up with, and then subtract one from the other. So in other words, we ended up at 5. We started at 1. So 5 minus 1 is a total distance of 4. All right, well, that's how we find rise and run on a coordinate plane. All right, and so basically we get this formula. The second point, p sub 2, this little number here just means the second point that we were talking about, in this case 5, the point we ended up at, minus p sub number, because it's below, p sub 1 means the first point, and that gives us the distance. All right, and so this helps us find the slope of lines when what we're given is the numbers, the coordinates. Let me try to clarify that. Let's say we're doing this problem. What is the slope of a line that goes through the points 4, 1 and 9, 7? Well, normally what we'd have to do is we'd have to draw a graph, we'd have to graph 4, 1, we'd have to graph 9, 7, and then I'd have to physically count the rise and run. All right, but I don't want to have to go through that trouble every time. So here's a way to find slope between 2 points without actually needing the graph. Okay, and again, once again, it's all about distance. If you think about it, rise is nothing more than a distance from one point to another. Run, same thing, it's just another distance just going horizontally. And so what we can do is we can use this same basic idea from this page, is take the point you end up at minus the point you start at, and that gives you the distance. All right, and so what we get is this. First off, I'm going to label these. This is my first point, and this is my second point. Okay, but we're going to be looking at them as separate coordinates. So what we're going to do is we're going to call this x sub 1, and all that means is the x coordinate from the first point. And we'll call this one y sub 1, the y coordinate from the first point. This one's the second point, and you can probably guess what those are going to be. It's going to be x sub 2 and y sub 2, the x and y coordinates from the second point. All right, now, what you then need to think about is, well, when it comes to x coordinates and y coordinates, which ones would be controlling rise and which ones would be controlling the run of our slope? Okay, well, if you think about x is how far across we move. To get to x1 or x2, I move across left to right. And so the x's control the run. So the x coordinates are all about finding the run measurement. Y, y1, y2 controls vertical movement. So the y's are where we look to find the rise. Okay. All right, and so what we would do is to find the run, we'd take the x coordinate we ended up at and subtract away the x coordinate we started at, just like over here. The point we ended up at minus the point we started at. 5 minus 1 gives a distance of 4. So we're doing the same thing here. Okay. To find the rise, we'd look at the y coordinates. The y coordinate I end up at minus the y coordinate I started at. All right, and so somebody put all this into a formula. Slope, which is rise over run, just becomes this. Rise, since it's on top, and since the y's control rise, we put those on the top of our formula. y2 minus y1. And that'll find us the distance between this point and this point in terms of vertical distance. The run, which is controlled by the x coordinates, x2 minus x1, finds us the distance, but it finds the horizontal distance from this point to that point. All right, so what we've got here is a formula which you should commit to memory that helps you find slope when you're given 2 points and you just don't want to bother taking the time to do a graph. All right, so here's what it looks like. This would be, let me get my pen here, y2, the second y coordinate, which is 7, minus y1, the first y-coordinate. Because again, the y-coordinates control vertical movement. So we've got a rise of 6. Now on the bottom, we've got the run, x2 minus x1. So 9 minus 4, which in this case is 5. And so that gives us our slope. This line, this imaginary line that we haven't even bothered to graph yet, has a slope of up 6 over 5. So it goes kind of that direction. All right, and I didn't have to graph anything to do it. I didn't have to count squares. I just subtracted x coordinates and y coordinates and came up with the slope. All right. So some of the trickier things to think about and remember is really focus in on the fact that we call slope rise over run. And the ones that control rise are the y coordinates, and run is controlled by the x coordinates. So that's why y2 minus y1 is on top of the formula and x2 minus x1 is on the bottom of the formula. Okay, because that's an easy one to get mixed up. All right, let's see one more example like that. What is the slope of a line that goes through the points -5, 3, and 4, -8? All right, so let's first identify what we've got. This is the first x coordinate, so x1, and this is the first y coordinate. Whoops, why did I do that? y1, and this is the second x coordinate of 4, and this is the second y coordinate, -8. All right, so let's find slope. Slope is equal to rise over run. So the rise would be the y coordinates. The y coordinate I finish at, -8, the y2, minus the y coordinate I started at, 3. In which case that would be -11. Then the run. The run is controlled by the x coordinates, so let's find that distance. 4 is where we ended up, x sub 2, minus x sub 1, which is -5. And 4 minus -5 would be 9. All right, so this line, which again, I didn't have to graph it, I found it out mathematically, has a slope of -11 over 9. So down 11 spaces, over to the right 9 spaces, so the line goes that direction. All right, so that's a bit about finding slope when you're given 2 points and you don't want to bother graphing it.